Okay. Students, we're going to be doing lesson 1.1, graphing of lines. This is where you want to be in your handout. Taking a look here. We are going, as you do this, please make sure that you also write down the location, the date and time, and get a parent or teacher sign-off. Okay, first we're going to do some review here. We're going to multiply and simplify the radicals. And when we do radicals, think outies and innies. Outies and innies. Let me show you what I mean here. I'll do the first one with you. Taking a look here, we multiply the outies. So you're going to draw a line from the 2 to 5. And we go like so, 2 times 5. And then we do the innies, square root 6 times 3. Now you actually don't want to multiply. The key to multiplying is not multiplying, it's factoring. Let me show you what I mean. So on the outside it's going to be 2 times 5 again, and on the inside we're going to factor that 6 down. So technically that's 2 times 3 times that 3 again. Now, whenever you have a double underneath the radical, we're going to pull it out. So circle those double 3s. We're going to pull them out. So we're pulling out another 3. Now we multiply. 3 times 2, which is 6, times 5, which is 30. And then we have square root of 2. So I want you to take about 30 seconds and do the one on the right on your own. Take a shot at this one on your own. All right, we take a look here, and you're going to end up doing the outies, which is 2 times 3, and then you do the innies. Root 5 times root 5 looks like this, so it's square root and 5 and 5. But that's already a date, so the whole thing comes out as a 5, and you get rid of it completely. So now we do 5 times 2, which is 10, times 3, and we end up with 30, and that's your answer. All right, now let's do simplifying the radical. Remember, when we simplify radicals, we start by doing a factor tree, and this is even, so I'm just going to use 2 all the way down. So I have 2, and then 2 goes into 112. That goes 5 times. 56. We keep breaking it down. Okay, now you want to look for your dates, and we're going to pull out the dates. So we have a pair of 2s, so we pull the 2s out. They come out as a single couple. And then we have another pair of 2s. They're going to come out as a single couple. And 7 has no date. So 7's going to stay under the radical sign. So just right now you put root 7. And then these guys on the outside we multiply. So we're going to do 2 times 2, which is 4, times 5, which is 20. So there's your answer there, 20 root 7. Okay, the last thing we went over in class was proportions, and there was a couple rules I had about proportions. Rule number 1, you always want to draw these cross multiplication lines, always, without exception. Next is you want to show the distributive step. So this is going to be 9, parentheses, r minus 9, equals 12 parentheses r plus 3. I want you to take a minute, do the math from there on your own. I'll show you the answer in about a minute. Do you see what I did? Katie, okay? Okay, so from here, we're just going to divide both sides by 3. And I'm going to go 3 into 117. It's a division sign. Make sure it's even, 17. And 3 goes in here 3 times with 2 left over. And 3 goes into 27 3 times. So, and that's going to be negative. So R equals negative 33. So that's your basic algebra skills you need for this class. All right, now the main lesson today is going to be doing graphing of lines. Warning, graphing of lines is literally going to show up on every single test and every single quiz we do for the rest of the year without exception. Graphing of lines is really important. It comes into play in prediction and statistics and curvature. Here's the vocabulary you need to be familiar with. The x-axis, the y-axis, slope, no slope, zero slope, slope-intercept equation of a line, point slope, equation of a line, standard equation of a line, horizontal and vertical lines. That's our vocabulary. By the end of the lesson, next 20 minutes, you need to be familiar with those. Okay, let's do our basic understanding. Slope is going to be rise over run. So go ahead. Slope is the rise of a line, which is up and down, over the run of a line, left and right. Rise over run. Now, a positive slope is a line that slopes upward from left to right. From left to right, if it goes upward, it's going to be a positive slope line. Let me show you an example of that. Let's put a dot at -6, 0. And let's put a point at 0, +5. Let's draw a line through that. Now, when I count out this slope, it's going to be rise over run. I automatically know it's positive. Put a little positive sign there. It has to be positive because it goes up from left to right. Okay. Now we just have to count our rise and our run. So you're looking at this right triangle here. So our rise, just bunny hop it. That's 5. And our run is 6. And I know it's positive from its left to right, so it's simply going to be my rise over my run. Now, a negative slope is going to go downward from left to right. So let's use that 0, 5. Now I'd like you to put a dot at 9, 0. Let's string a line through 0, 5, and 9, 0. Now that's a negative slope because it's going down, so immediately I know whatever my rise and my run is, it's going to be negative. So just stick a negative sign there. Let's count our rise over our run. Our rise we already know is 5, and our run is 9. So it's going to be negative 5 over 9. All right, zero slope. Zero slope comes into play. Remember, it's rise over run, rise over run. Zero slope comes into play when our rise is 0 and our run is a number. So that means if I have 0 rise, that means it's a completely horizontal. It's a flat line because there's no rise. Does that make sense? No rise, so it's flat. Okay, that's 0. And if we come here, rise over run again, and we have a number in the rise, but we have 0 run, that means we have no left right. That means it's vertical. We call that no slope or undefined. So a horizontal line is 0. A vertical line is no slope. 0 and no slope are not the same thing. Now I'm going to show you how to graph horizontal and vertical lines. Y equals 6. When we graph y equals 6, it means all the points where there's a something and a 6 there, because y equals 6. We have a something and a 6. The easiest way to do this is to just graph a bunch of lines that is something 6. So we're going to graph here, we're going to graph, let's graph 0, 6. Ready? 0, 6, it's right there. Now put a dot at 1, 6, 2, 6, 3, 6, 4, 6. Do you see what's going on there? So y equals 6 is actually a horizontal line going through y. That's y equals 6. X equals negative 5. That means all the points where there's a negative 5 and a something. So now your X is negative 5. Again, the easiest way to graph this is just a bunch of points. So we're going to do negative 5, 0, negative 5, 1, negative 5, 2, and let's see what we get. Negative 5, 0 is right there. Negative 5, 1 is right here. Negative 5, 2. And if you just keep going, so x equals negative 5 is going to be a vertical line right there. X equals negative 5. Okay, slope-intercept equation of a line. This is the one you're most familiar with. Let me write the equation out. It's y equals mx plus b. That's what you're used to seeing. So mx plus b, y equals mx plus b. Okay. Let me show you how to graph that. Step number 1, you're given an equation right here. I want you to write this equation right underneath it, always. Line it up, so just write the equation. So we're going to have y equals mx plus b. Our first step is to find our y-intercept, so we circle the b and the -5, so our y-intercept is -5. And now go and circle the slope and circle what's right above it. That's going to be 2/5 for the slope. Notice it's a positive line, so immediately sketch a little baby line that's positive, so you know that line's going to tilt up from left to right. To graph this, all we do is we plot the -5 on the y-axis, so trace the y-axis. Now plot -5 right there. Now we count out our rise and our run, and we want our line to tilt to the right. So we go up 2, that's our rise, and over 5, 1, 2, 3, 4, 5. There's your second dot. Now you want to graph your line. Okay, I'd like you to take a minute and do the next one completely on your own. And then I'll come back and check the answers. Ready, go. All right, let's see how you did here. So we start by writing out our equation, which is y equals mx plus b. And we see here that our b is going to be +4. That's our y-intercept. And our slope, that's 3 there, but technically it's 3/1. So we do this. We start at 4 on the y-axis. We put a dot. That's our y-intercept. We know our line's going to be positive this time because it's going up from left to right. It's okay. It's okay. So we're going to go up 3 and over 1. You could also go down 3 and over 1 this way. And there's your line. Okay, so that's y-intercept. That you're familiar with. Standard form takes a little bit more effort. Standard form looks like this. ax plus by equals c. It's easier. It's just going to be something x plus something y equals something. There's 2 ways to do this. The first method is to change everything to y equals mx plus b. That's the slope-intercept method. So write that equation, y equals mx plus b. Your goal here is to get y by itself. So rewrite your equation here, 3x plus 4y equals 12. I take a minute and just circle the y there or highlight it. Your goal is to get y all by itself. So first what we're going to do is we are going to minus 3x. Our next line reads like this. 4y equals. You can't really subtract these. So I'm just going to bring the x forward. Negative 3x plus 12. Now we're going to divide by 4 so we get y by itself. And my final answer here is going to be, I'm going to bring it up here, y equals negative 3/4 x plus 3. Now we're going to graph that. So we're going to start at positive 3 on the y-axis. And then my line's going to go downward from left to right because it's negative. So I go down 3 and over 4 this way. Or I could go up 3 and over 4 this way. Either way, there's my line. That's called changing to slope-intercept form. You get y by itself. Now another way you can do this is using what's called your x and y intercepts. So rewrite your original equation, 3x plus 4y equals 12. Now, you're going to make what I call owl eyes or wally eyes or some other notation. You're going to go blank, comma, 0, and then you're going to go 0, comma, blank. That red is your x-intercept. So what you imagine, that's y, correct? Imagine, I should read y. Imagine if you put a 0 in the y, it simply makes it go bye-bye. So I end up with 3x equals 12, and if you solve for x there, divide both sides by 3, you end up with 4, 0. That is your x-intercept. Now if we do this one, you put a 0 in the x, so come over here, and now you say goodbye to the x. We're going to end up with 4y equals 12. You solve, and you get y equals 3. Now you plot those 2 points. So we're going to have 4, 0 right here, and then 0, 3 right there, and you can see it's the same line. So you can use intercepts, or you can use y equals mx plus b. I'd like you to take a minute and use either method to graph this line right here. Go. Okay, let's see how you did. I'm going to change it to y equals mx plus b here. So I have a 2 fat pen. Let's see here. I have 6x minus 2y equals 18. I'm going to start by minusing 6x minus 6x. I end up with negative 2y equals negative 6x plus 18. I'm going to divide both sides by negative 2. And I end up with the line y equals, that's negative 6, 3 over 1, x minus 9. Or I can do intercepts. My intercepts are this. Remember, it's blank, comma, 0, and 0, comma, blank. So if I put a 0 in the y, I go like this, a 0 in the y, and I have 6x equals 18. You know that that is going to be 3. So 3, 0. Then, if I come over here and I put a 0 in the x, so now I say goodbye to the x, divide both sides by -2, you know that's going to be -9. So let's graph by that. 3, 0 is right here. And -9, 0, -9 is right here. Now we're going to graph them. And let's see if that works with our equation of a line. Our equation of a line, we start at -9, and then we're going to go 3 over 1. Up 3, 1, 2, 3 over 1. Lo and behold, it's the same line. Okay, there's one more equation of a line. It's called point-slope form, point-slope. It's y minus y1 equals the slope x minus x1. Y minus y1 equals slope x minus x1. That's called point-slope equation of a line. You use it when you have a point and a slope. We're going to do two things. So we want to graph a line. We want to graph a line that goes through the point 1, 3 and has a slope of -2. This is really easy to graph. We start by graphing the line 1, 3. Graph the point, excuse me. So we go over 1, up 3, and that is going to be 1, 3, the point. Now we're going to count out the slope. The slope is technically -2 over 1, so we know it has to go downward from left to right. So I can go up 2 and over 1 to the left, or I can go down 2 and over 1 to the right. Same thing. And there is my line. Now the second thing I want you to be able to do is write an equation of a line into the slope-intercept form using this. It says write the slope-intercept equation of a line that goes through this point and has a slope of. So this is y equals mx plus b. That's what we want. So we want a y equals line. But it goes through this point. Let's make, our point is 1, 3, so this is going to be x1. This is y1, and this is our slope. Let me bring this closer so it's easier to see. Let's write our equation of a line here. We have y minus y1 equals slope x minus x1. So this is our y1 right there, and then we have slope, and we have your x1 right here. That's your equation. Now let's start plugging stuff in. Your x1 is going to go right there, your y1 goes right there, and your slope, of course, goes right here. We're going to plug stuff in. So end up with y minus 3 equals -2 parentheses x minus 1. Now, our goal is to get x by itself. So first thing we need to do is work out this distributive. So draw the little distributive arrows. And we're going to end up with y minus 3 equals -2x plus 2. It's plus because that's a double negative right there. Last but not least, go ahead, we're going to add 3 to both sides. And our final equation is going to be y equals -2x plus 5. Let's see if you did this correctly. -2x plus 5. So your intercept is going to be +5. +5, which we have. Now let's count on our slope. Down 2. Over 1, down 2, over 1. Lo and behold, it's the same line. So There is our line, and there is our equation. I'd like you to take 2 minutes, and I'd like you to do this page on your own. So I'm going to put the timer on for 2 minutes. I'd like you to both graph that and write a slope-intercept equation of a line like you just did. You have 2 minutes, go. Alrighty, let's see how you did here. Okay, step number 1, you want to write the equation. So you should have the equation written down, which is y minus y1 equals slope x minus x1. So now we want to graph a line that goes through this point. So just plot that point. So we're going to go over 4, up 6. There we are right there. 4 comma 6. And we have a slope of 1/2. It's positive, so our line should go like this. So we can go up 1 and over 2, or down 1 and over 2 this way. And our line should look something like this. Okay, now let's use this information and now write an equation of a line and see if our equation matches with that graph. So we start by writing y minus y1 equals slope x minus x1. Now let's start plugging stuff in. That is going to be your y. So you should have 6 right here. And then your x is this, 4. That's going to go right here. And then your slope is 1/2. So we have 1/2. Now let's bring everything else down. So I have y minus 6 equals 1/2 x minus 4. We distribute. And we have y minus 6 equals 1/2 x. Half of 4 is 2. And now I'm going to add 6 both sides. And my final answer here is y equals 1/2 x. Negative 2 plus 6 is going to be positive 4. Let's see if this actually matches with what we had. So we start at the 4 on the y-axis, which is right, lo and behold, it's right there. And let's count out the slope. It's down 1, over 2 this way, or up 1 and over 2 this way, same line. Good job.